Good day to Sir Prajendra. I'm Hor Wai Keat. I'll be presenting our Data Analytics for Engineers group project with my partners, Mohd Syahzani and also Vikneswaran. So start off with the introduction and objective of this project. So in this project, we're given the data collected from electricity smart meter at the houses. So we are required to predict the GHI according to the data set using the data analytics skill that we have learned in the class. So we'll use the supervised learning method to perform the prediction based on the data, since we know the target variable, which is the GHI. So the process that we will perform is based on the data science pipeline, which start off with the data acquisition, data preparation, exploratory data analysis, data modeling and evaluation, and finally interpretation and reporting of findings. So start with then continue with the data acquisition. In data acquisition phase, we are required to find and gather the information of the data set, which includes the number of columns that the data set have, the format of the data, for example, what type of the file, Excel or others, and sources of the data set. And on the right is the code to read the meter data in Excel file. And continue with the data preparation. So in data preparation, we are required to obtain the overview of the data, check the data frame which needs to be understand the structure and content. And on the right, we have used the dot describe function to obtain the count, mean 25%, the median 75%, maximum and standard deviation of the data. In the data frame, it contains the data which need to be used in the analysis part. And on the right, we analyze the code and make sure it's ready to be used and plot in graph illustration. We also fill in all the missing values with the mean approach, which is the data imputation, to ensure the data do not have bias when interpretation later. And we also remove invalid data and blank value if the data scale is too small. And now I'll pass the presentation to Mohd Syahzani.
Thank you, Wai Keat. Hi, my name is Mohd Syahzani, and today I will present the exploratory data analysis. In exploratory data analysis, it is done to find the structure of the data. In exploratory data analysis, we can either use univariate, bivariate, and multivariate visualization. In our approach, we have decided to use bivariate and multivariate visualization. Let's look into the first one, which is the correlation heat map. The purpose of the correlation heat map is to get the correlation between the variables in the dataset. As we can observe here, there are 8 variables have been chosen and being put at each side of the heat map. By looking at the right side of the heat map, we can see the color range of the heat map. The green color shows positive correlation between variables, while red color shows the negative correlation. We can observe that GHI and export have the highest correlation. GHI and export have the highest correlation. The second highest correlation is GHI and air temperature. Based on the heat map and correlation obtained, we have decided that the target variable would be the GHI. Next, we go to scatter plot. The purpose of the scatter plot is to illustrate the relationship between numerical variable. Other than that, by using the scatter plot, we can find the relationship between different pair of variables. From the observation, I can tell that there is positive trend between GHI and air temperature. This shows that as solar irradiance increase, the air temperature tends to increase as well. Besides, the variable cloud opacity also reveal how it affects the solar irradiance. But now we are focusing on air temperature and GHI. Next, we go to scatter plot between GHI versus air temperature. The purpose of this plot is to fully get the relationship between air temperature and GHI. It helps us understand how GHI affect the air temperature. At high temperature, GHI are uniformly high and the air temps is also high. For the observation, Higher temperature coincide with higher GHI can help in optimizing energy production and managing thermal loads when using solar energy as the resources. To conclude, we can gain valuable insights into how these two environmental factors interact, which is essential for both scientific research and practical applications like solar energy management. Thank you. That's all for EDA. Next, I pass to Vikneswaran.
Thank you, Syahzani. Now I'll be presenting the data modeling and evaluation part. For the data modeling part, we actually aim to leverage machine learning to solve the limitation of human skills in predicting the global horizontal irradiance, also known as GHI. We actually employed the gradient boosting regression algorithm using the air temperature feature to predict the GHI target variable. As you can see that our data set was actually split into training set and also a test set, with 24% of the data reserved for testing. We actually use random state of 42 to ensure the reproducibility of the results. The model performance was evaluated using several evaluation metrics, which includes mean absolute error, mean squared error, and also root mean squared error. As you can see from our scatter plot, we actually examine the relationship between the actual GHI values and uh, predicted the GHI value using our model. As you can view from our scatter plot, the x-axis actually represent the air temperature data, while the y-axis represent the GHI data. We could observe that the GHI values varied significantly with the air temperature. But interestingly, the model prediction was slightly less accurate for low air temperature compared to the higher air temperature. Here we have the evaluation metrics for our model. As you can see, we actually able to figure out the mean absolute error value, the mean squared error value, and the root mean squared error value. For the mean absolute error value, we actually got 117.02. Uh, for the mean squared error is about 29,734.29. And finally, the root mean squared error is 172.44. Additionally, our model achieved an R squared value of 0.59 or 59%. Moving on to the conclusion, uh, in conclusion, the valuation of predictive model for GHI indicates a moderate performance. While the model captures some variability in the GHI, as evident by the R squared error of 0.59, the prediction errors are relatively high, as shown by the mean absolute error, mean squared error, and the root mean squared error values. So in order to improve the models, our team recommends exploring additional relevant features, uh, in considering more complex models, ensuring high quality data pre-processing, and performing hyperparameter tuning. So by addressing all these areas, we could potentially enhance the model accuracy and reliability in predicting the global horizontal irradiance. So this is our conclusion and the end of our presentation. Thank you.